using R for the past year, so I'm not that great at it either, but I've kind of been playing around with ggplot2, and I've been plotting a few graphs for like poster presentations and stuff. So we're kind of going to go through the basics so you get a gist of the point of this package. So ggplot2 helps create customizable figures. So it's grammar of graphics, so hence the GG part. It's a very flexible package, so it allows you to make modifications based on what you want to plot and how you want to make changes that is appropriate for the figures that you want to make for either manuscript or posters or any type of presentation. So it's pretty much like a building block, so you need various things to create your figure. So again, obviously you need your data, and at this point you'd want your data to be cleaned up and ready for plotting analysis. And then there's aesthetic mapping, so how data are mapped based on like color, size, position, geom, so geometric objects or marks like points, lines, and shapes. Facets, and this kind of separates the data into subdata when you're creating your figures. Statistical transformations, scales, and coordinate systems. So basically when you're trying to code for ggplot, you follow a kind of a pattern where you identify the data set you're using and the variables you want to extract, and then you talk about like you indicate the statistical changes and then all of the pretty things that you want your figure to end up looking like. So this is just like a basic output of how the data could be presented, but it can get much more complicated and you can make a lot more adjustments and even create something that looks kind of like this. So we'll start with a brand new R script page, and just save this onto my desktop as ggplot practice. You can just create one for yourself. So first you'll need to install ggplot. So just install packages, ggplot2. Packages. And then just get it from the library once it's installed. So that just lets you use the actual package. Now the nice thing with this package is it comes with some data frames that you could use. It's a good way to practice the different types of figures that it lets you produce. So today we're going to use a data frame called MPG, and that's the miles per gallon. So the data set contains a subset of fuel economy data, and these are the variables that are in the actual data set. So we can look at the actual data set. For example, we can look at a summary. I think Luke went over this type of observations for the data set. So you can kind of see here in the console, it gives you the different outputs from the data set. If you want to look at it on a separate screen, again, you can assign it. So I tend to like to do this. I know sometimes it's not that great to have another one, but I don't know. Like sometimes I just like to take a quick look at the whole data set, and that's kind of what I do. Again, if you want to look at the column names, you can just do that, or column names, they do the same thing. So this is just for you to kind of get a sense of the data set. That's all we see. Column. Yeah, so they have the same output. Okay, so we're gonna start with simple figures. So looking at, say, one variable, you want to look at the distribution of it. For example, through a histogram, you can start with the first assigning a ggplot, and then you would identify the database you're using. So here we're using MPG, and then the variable you select. So if you can see here, these are the various variables in the data set. So we can select highly. That kind of just selects the specific variable you want to look at. And then if you want to create a histogram, you would put geom. And as I mentioned, this was the first main building block where you select the type of data figure you want to create. So if you just put geom underscore, it gives you the various options you have. So you can see here there's lots of options what you can create.
And geom is for histogram?
No, geom is just identifying which ones you want to create. So you can do histogram, bar graph, point, etc. So that's just kind of how you indicate what you want. So, yeah.
Geom just indicates air. It's like a sheet of paper. Geom is like just a sheet of paper. Stack. You have multiple genomes.
Okay.
Yeah. So geom, and then if we start typing histogram, you see that shows up. And if you put tab, then if you highlight the whole 2 lines and enter it, it will generate a histogram based on the highway data.
I cannot see very clear.
How do I make
This
it
is a
dark?
class.
Yes, yeah. So with ggplot, because you're layering things and building blocks, you're adding. So you put plus instead of the pipe symbol. So that's just like a general histogram output on the highway data.
Yes.
So when you just have histogram with the brackets, you're accepting all the default settings. So I tend to use this when I just want to look at the distribution of the variable real quickly. Another one that you could look into is, again, using the same variable or looking at, yeah, you can use the same variable. Geom density. So again, this kind of shows you a different output of the same data. You can kind of see the distribution. So if we compare the two, you can kind of see how the trend looks. If you wanted to plot something of discrete data, you could use another type of plot. It's a bar graph, for example. Class of cars that's available. Bar. So a bar graph, bar, straightforward. So again, you can see here that the different class of car types are here. 2-seater compact, let me make this a bit bigger. Minivans, and then it shows you the count for the data. So again, this is accepting all the default settings for the type of graph that you're using. So these ones is looking at one variable. If you want to look at 2 variables against each other, for example, through like line graph, it's the same idea. So again, ggplot, data set, and then aesthetic, you select the variables that you want to look into. So in this case, we'll look at display and highway, and we can make the so scatter plot. So yeah.
Why do we change ggplot MPG, AES class or 8 WY?
Yeah, so this is just looking at the different columns within database.
Okay.
So I just randomly selected that. So you could pretty much replace it with anything that's in the data set.
So it's the other columns.
Yeah. And then for the point, it's going to go against the 2 variables. So you can see here the scatter points here. So that's the engine displacement in liters versus the highway miles per gallon. So that's the relationship it's shown for the data. And you can even plot it again with a line graph. There's really lots of options that you can explore when you're looking at when you want to plot the data. Okay, plus geom underscore line. You do this, you can kind of see the line graph of the data. So you can see how it uses the data to plot the figures pretty quickly. Another nice thing with the ggplot is that you can create a regression line on the figure. So if you put geom_smooth after the point of the figure that you identified, you put plus geom_smooth, and then if you run that, you can kind of see it follows the trend of the data. It outlines a general regression line, which is pretty nice to see when you just want to look at general data.
That's called a loss.
Yeah, this one, the default is the lowest line method. You can specify using a different methods. And this, takes into account the. So that's a different method you can use when you're creating the regression line. Linear model.
Stands for locally weighted scatter plots.
The lowest? Yeah. So I'll just put the default. The 2S? 2S?
Yeah.
Yeah, so the default's that, but you can select the other ones in there. Another nice thing you could also plot within the figure is quantiles. So again, ggplot, npg, same data set you can use. So I'm just showing you the different things you can do in general with this figure. Sorry.
Oh, okay. So quantity.
Okay, well, it worked on my desktop.
You probably have the.
Okay, well, if you install that one, it would do it. Okay, we'll ignore that one for now.
You can try it. As well.
Install. Because I didn't install it already in there. I don't have to do coverage. Okay, so then you can have the quantile lines on the actual figures if you want it. Yeah, and then okay, well, I won't talk about it.
Library for
Oh yeah, sorry. I'll put that here. You have to install it because it's not part of your actual. If you run that, you can see the quantile. So just 25, 0.25, 0.5, and 0.75. Yeah. Okay. And like I said, every time you just have the two brackets in here and you don't write anything in there, you're accepting the default settings that are already part of the function. So for this one, the default would be 0.25 line, 0.5, and 0.75. But you can always adjust that. So if you were to type in quantiles, let's see, 0.1, 0.3. So I'm just randomly selected this one. You generate different set of lines. So a bunch of lines will appear, which is pretty cool. Now another thing that's really cool with the ggplot is the function of facet. So that generates subset of data within one figure. So we can do that real quick. So again, same. So let's say I still want to do a geom point. We would do facet underscore grid. And then let's say I want to subdivide the data based on the drivetrain. So it takes the relationship for the what's called displacement, the engine displacement and highway miles per gallon, and divides it by the drivetrain group. So the 4 wheels, front wheels, rear wheels groups, subgroups. So that's kind of what facet does. So you can see it divided the data based on those 3 groups here. And I like this, especially like if you have data that you want to group it by sex, so you can look at the difference with male and female, so you can kind of subgroup that. If you see here within the bracket, I have a dot, tilde, and then the variable. That just means that you have just general one row, and then the columns based on the variables. So this DRV has 3 subgroups for it. So the columns become 3 here. If I switch, so let me just write that here, row, column. If I did the same, but interchange the period to after, it should create 3 rows instead of the 3 columns. You can kind of see. So you can just play around and see like which way you like your figure to be shown. So you can do either 3 rows or 3 columns for that. So I think that the facet one tends to be pretty useful, especially when you want to put a lot of data onto a figure. It's the tilde sign. Here's the squiggly line above the tab. This one. Is that why it was wrong? Is it working? Oh, DRV. Oh, not DR1. Yeah, this screen is not very good. I'm gonna make it darker. Like, do you know how to make it like darker?
I would say make it bigger.
My font bigger? But like even the figure doesn't show up the same. It doesn't do anything. Okay.
Yeah, this is cluster analysis. Just like making clusters of an analysis.
This is just like plotting the thing from the actual data set that's there. So it's subgrouping the data. Yes.
Just like clusters.
Yeah.
It's not technically cluster analysis, but you can use it to really
Oh.
like especially in the exploratory phase. See what's going on, and if you see something, then you can.
And then with ggplot, you can also create boxplots. So again, so the trend here, you can kind of see, you first write ggplot, then data set, and select the variables, and then the type of figure, and then you can make the changes after. And you're always adding a plus sign because you're adding the layers to it. And then boxplot, it's pretty easy to find the figures you want to. And we can can see here, you can generate a box plot pretty quickly. And then you can implement the facet function here again if you wanted to separate this based on the cylinders, for example, in this data set. You can see how that works. That's pretty cool. You can see the difference in the classes for the different types of cylinders, like 4, 5, 6, and 8. So this is just the general overview of how ggplot can plot data pretty quickly. But you can obviously make a lot of customization. So we're going to go through 2 big examples, and I'm just going to show you how you can make modifications on those examples to generate the kind of figures that you want for whatever you want to create it for. So let's have example 1. So again, the same thing, you do ggplot, identify your database variable. So let's do a again, and we're gonna do a point here. So again, we did this earlier, but I'm gonna show you how you can make modifications here. So if you were to type here point with the question mark in the console, that just lets you get information about that particular function. So it shows up in the help tab. Okay, so you can see what the various changes you can make within that function. So the arguments here is just mapping data, stat position, and stuff. So you can, if you are unsure of what kind of changes you can make within a function, doing the question mark and then the function name gives a lot of good information, and then you can play around with the different changes within there. So let's say for this particular one, we want to change the color of the point. So if we go back to the figure it generates, you can see there's black dots everywhere. Let's say you don't like the black and you want to change the color. So you just do color equals, and then in quotes, the color that you want it to be. So let's say I wanted to change the dots to blue. Just type out blue. And then you can see the colors of the dots change now to blue. So that's one nice thing you could do within that function. You can even change the size of the dots in this function. So let's say we'll make it size 3. If you run it again, you can see the dots just got larger. I'll do new code so then you can kind of have the different ones available. So sometimes like the points would have multiple data that have the same like displacement versus highway data. So if you want to see the transparency with the amount of points within a certain spot, you can change the alpha level, which is the transparency. So right now it's at 0.1. It's at 1. So if you make it less, you can see the difference. So I'll show you. So you can see here there's fewer, lighter shades around. You can kind of play around with that.
Why did we do that?
So you can see the density of the points that are there. So you can see how much fall into various displacement versus highway. So that's pretty useful and cool. So this is pretty much what
It's,
Screen is so small. Sometimes instead of having, like, for example, facets, you can group it based on colors. So right now it's all blue here, but what you can do instead is, rather than doing all of the colors as blue, you can color it by a certain group within the data set. So just copy that. You would do aesthetic, color, equals, and you just pick your variable. So in this case, so here you can see that it grouped it by color, the different data for the displacement versus highway, based on the four-wheel front and rear wheel drivetrains. So you can kind of see the group where they lie for the different types of drivetrains. And you can see here, I put aesthetic instead of just straight color, and that's because you're identifying the variable within the database. So you'll have to type in this before you actually put it. If you put color equals DRV, it wouldn't generate anything. Ooh, bless you, or Robitussin. I don't know what that was. So, like, yeah, see, if you just put color equals, it wouldn't be able to generate anything.
Your basic variable,
Yeah. So if you look at the data set, you'll see again. And if you want to, again, add another layer of that geom smooth here, you just introduce it after, and that would create that line. And if you want to make that the linear model. So if you see your figure, you're like, I don't like how the axes are labeled, and you want to make modifications because it just takes the names from the variables that are in the data set. Usually those are not the full name of it. So what you can do is type up lab for label, labs. And then you can identify what titles or change of names you want to do. So if you want to add a title to this, you would just type up title equals, and then in quotes, you would put whatever title you want this. So let's call this fuel. And if you want to replace the x-axis title, you just put x equals engine displacement. Just put commas in between. Y equals y. So now the axes are changed, and there's now a title that's on your figure. then you could even change the background color of your figures, because you see there's a gray background. Say you want to make it all white and change the font style. You would put theme. Yeah, that's what I'm saying. It doesn't. Oh, is that what they see on this? Yeah. But you'd see it on your output. So theme kind of changes like the actual look of how the figure looks like. So if you put question theme on the console, you can see all the options you have. And I haven't even used a lot of these, but it's nice to play around and see what they do and how you can modify things. So I'll try to use up a lot of them in the examples. Well, not a lot of them, but some of them in the examples, so you can kind of see what they, yeah, it wouldn't be possible to use all of them, but you can kind of see like how they work and what changes they do. But yeah, theme comes in handy when you're trying to make it pretty. Oops, where's the fonts? Okay. So let's say I want to change all the font to Times style, then you just do that. Why is it telling me? Okay. So you can see how the font changed now. So you can make changes on the font and how the background looks. So right now the background is all white. So you kind of get the idea of how you're layering the changes as you go. So it's nice to have the big picture, and then over time you kind of see what you want to modify. But you're trying to tell a story with your figures, so you want to make it as clean and clear as possible.
I think it's okay, but I do not get the picture exactly. So I don't know the code.
DW base family equals times. Oh, that's weird. Okay, yeah, I think there's a problem here. Labs title equals. Oh, you need to put a comma here. That's why the titles didn't change. So if you put a comma here, because you're separating the different ones, and let's run it from here. You forgot your plus. So every time you're adding a new one, you need to add a plus because you're layering, right? So that's why it's not showing up for those ones. And if you don't have the same output as mine, just let me know. But see, like if you run each of them by line and just don't include the plus, you can see what each of the functions does. So again, oh shoot, what did I do? Well, you know, if you did it line by line before the plus sign, you'll see the different changes. And I like doing that when I'm making my figures, because then you can see what changes you're applying every time. So does the font change, right? It went to times function. Work?
Yes.
Okay. So let's say like for your figure you wanted to change the size of the titles. You just put plus, again, theme, and then title equals element underscore text. So you're changing the element of that particular text. And you could just put whatever size you want. So let's say I want my title to be huge. Is that huge? I don't know. Yeah. So then the fuel economy title increases in size. You can even modify the axis title size. So I did axis dot. equals element text. Just randomly putting a number just to see what that would be. Yeah, so you can just modify the actual title size. And then you can see here that the actual like text labels are pretty small, so that can also be adjusted. So everything you see in your figure is pretty modifiable. You just have to find a function that will do what you want to do to it. And the good thing is there's a lot of online sources that help find the things that you want to make changes with. So that becomes pretty handy when you're trying to search the different things. So text element. Let's say, I'm just gonna play around with the numbers to see how they look. So like now you can visibly see the different numbers on the axes. Yep. So you can see how much longer the code is, and each time you're just adding layers to it. So each time I'm adding a plus sign and adding the changes I want my figure to undergo.
I have to run everything from the beginning, or
Well, if you want to, yeah, you run the whole code chunk that you're creating, right? Otherwise, it wouldn't know what you mean. Because you're building to it, right? So you'd have to run the entire chunk. It looks the same? So you get that. And let's say that you ran a correlation test and you wanted to include a p-value on your figure. That function is known as annotate, which makes pretty sense.
so let me write. I'm doing this in order to add the value.
Yeah, or whatever you want to include within the figure. Yeah. Okay, so then you're going to add a text. So you identify that it's going to be a text. And then you put where you want the actual text to lie. So you would identify on the x-axis where you'd want it. So let's say I want it on 6 for the engine displacement at 6. And then on the y around, I don't know, 40. That's kind of the position you're saying that you want the text to lie on. So, and then you type out the actual text that you're putting. So p-value, let's say 0.0. So generate that. Why did it not work? Oh, whoops. Save what you're making. Yeah, so then the p-value should show up where you assigned its position to be. Or whatever text you want to add. So you'd actually calculate the p-value separately. What? No. Let me see. Oh, remember you have to add a plus sign. Yeah, label and then add a plus sign at the end because you're using a function with 2, so you're close it up.
I'm doing all of it now.
And every time you want to make a note, put a hashtag in front of it so when you do run the chunk, it doesn't include that as well. So yeah, make sure you have the add plus sign there.
Yes.
Yeah?
Yes.
And you can see the p-value it appeared now. And the p-value is kind of small for this figure, so you can even adjust the size. So if you were to type in size equals whatever number you want it to be, so let's put like 7. Okay, so that's here so you can see. You can see it became much larger. So again, you could see what other changes you can make with the annotate function by just putting the question mark annotate and then read about it in the help tab. Anyway. Okay. And then again, if you ran like an R that you want to include in the figure, you'd do the same. Again, you'd identify that you're putting a text, where you want it, what you're typing up, and then if you want to make changes to the size, you can include that as well. So that's just how, this is just an example of how you can build up a figure. So if you look back with all the changes that we've done, we went from a really simple figure to something that's much more customized to what we want our output to look like, right? So we can do another example. That was example 1. We can see that each time we're adding a new function to it or changing it, we add a plus sign because we're building onto the figure itself. So we'll do another example real quick. So again, ggplot, the data set you're using, and then we're going to do a density example. So for aesthetic, we'll select a variable for x equals highway, and then we'll fill it or divide it based on the drivetrain. So do that. So we'll just see how this generates the figure. So here when we put fill, it divided the actual data of the highway in terms of density output that we want by the drivetrain. So you can see, that's why you have the 3 different colors here. And you can make adjustments to this since it's all solid colors. Maybe you want to see what's happening behind this blue color. So you adjust the transparency. So the alpha level will make it lower. Let's say put it as 3. You can see now it's much transparent. And let's say you don't like how the color looks like. You just do again plus sign and then change the color style. So this option, you just assign it to the color that you want. So the palette will be and I think if you put question mark scale, it will give you, yeah, it can give you the different options to enter in for the palette. So you can see the different types of color schemes out there. So let's just select this one. So you can see it changed from that color to this color. You can just modify it as you go if you don't like that. So again, you'd use the theme function to make more changes to the actual figure. And let's just create, let's say, a border around the actual box that we have here. So if you put panel dot border element rect, that gives you the rectangular border around the figure that you have. And you want to type in color and just pick a random color that you want the border to be, say red. See that it just created a border around your figure. And maybe we want to get rid of the gray background because there's already colors there. You kind of want to make it stand out more. You can get rid of that gray background and even like emphasize the grid lines. If you just, within the theme function, enter in panel dot background blank. So we're making that blank background. And then if you enter in panel.grid.major, you can color in the actual grid lines within your figure. So specify what color you want. So say. So here we got rid. So the panel.background got rid of the actual background color that was gray, and then we just emphasized the grid lines and just selected the color gray for that. Were you able to generate that?
Line. I'm not used.
Yeah.
I'm not seeing if that problem is here in field.
Palette. So make sure that so if you ran just this section, you'd see that the color would change. Did it work? Yeah, so you saw the color change here. And then I think if you run the rest, it should do it. Yeah? So now it looks the same. So you can see like we modified the border. You don't even need to have a border. If you want to get rid of that, it's fine. And then we got rid of the background color and emphasized the grid lines here. So again, just like the previous example, you can change the size of the labels. You can add titles to this, change the size of the axes. What else? Oh, see here that there's a legend that appears because we've subgrouped it by the drivetrain. So you can even modify the legend that appears. So if we within the theme. You can, right now the legend is here, but you can position it either top or bottom as well. So if we put legend Position. Top. The legend moves to the top. So you can play around with where you want that part of the figure to, the legend to appear on your figure. Yeah. And then here it's still using the variable name DRV, but again, obviously when you're having your figure, you want to be able to explain what that means. So if you were to add another layer called scale_fill_discrete, you can change the name of that to what it actually is. So this would drive trampoline. And that should change the DRV to what you specify it to be. And again, the for, F, and R is not that useful if someone does not know what this data set is. So you can change that as well. So for the breaks, since those are the three categories, you just identify which ones you want to change. So when you put C, it's like you're grouping the ones that you're trying to change. And then when you put labels, you're identifying the same order as what the breaks are set as, the changes you want in terms of the label name. So for and you can see at the top the legend now describes what each of the colors mean in detail. Okay. So that's just the second example that we had for generating a figure. So if you were to go line by line, you can see how much changes you did by just doing these types of code. And the nice thing is once you have a code that's pretty much what you want it to look like, you can change the variables and have the same output, make your figures all look similar. So when you generate the figure, like for example, this one, it's nice, but you need to export it to add it to your posters or manuscript. And I think Luke will be talking about R Markdown, or you've already talked about it. Are you going to be talking about it? Yeah, so there's another way of generating manuscripts and stuff where you can already include the code chunk. So when you put the output, the figure generates automatically. But if you wanted to have as separate files, you can either export it through this button here, but it's better to have it as a code. So what you'd have to do is assign the entire code chunk into a name. So let's call this example. And then you would just assign it. And so if you ran the entire thing, including the name that you gave it, it would appear in your environment. And using that, you can save your figure to wherever on your computer. So first you want to check where you're saving it to. So if you type get WD, shows you where you are set as right now, and you can change that to wherever you want to save your figure. So let's say I want to save my figure example onto my desktop. Just have to change where it is right now. So you do this for whatever it says on your own computer. And then you would use ggSave and name what you want the output to be. So example figure.png tends to be a good one to generate your figures with. And then identify which figure you're trying to export. So we named it example. The nice thing with this type of export, rather than just clicking the export button, is you can specify the clarity based on the DPI. Was it pixels? Something pixels? I don't know. First, that should make it pretty clear.
And one thing already is not using this specify in the path.
Oh yeah, in the console, right?
I would even never
Change it? Oh, wow.
because the point of having a file certain record in the first place is to save wherever you want it.
Oh, well, mine is on the base. That doesn't make sense. Mine was on this. Yeah, so I had to specify it.
But you could specify it in ggSave. Because now
Oh, here?
Yeah.
Oh, really?
Yeah.
Oh, cool.
That would be a better location.
So what would you do?
So
Oops.
ggSave. So
And right here you
write down slash user slash slash.
in quotes.
Yeah.
So you'd enter all of that. Yeah.
All as one, including the property.
Oh, with this too. I didn't know that.
It's better to not move around.
Okay, well then we could do that. And you don't need this. That's even simpler. And then you don't have to go back to your original working space. Cool. Sorry. So I saved it to my desktop, so it should be there. Yeah. So the figure was saved onto where I told it to. So this is pretty much just the path that you're identifying for the figure to be saved on. And the nice thing is here, when you actually run it, it tells you the size of the image, and you can play around with that and change it. So we could even type in here width equals, I don't know, 7, height equals 8, and if you run that again, it would save it with the adjustments of the height and width that you've set. And if I go back to my desktop, oops, what's wrong one? This personal information. The size of the figure actually changes. Yeah, so that's just kind of like a really brief overview of what ggplot can do. There's a lot that it can make changes to a figure that I have yet to with, but these tend to be useful for just general figure generation based on whatever you want to create for a poster or manuscript. Any questions? Oh, and if you want resources to help you out, there's a lot online, but the ggplot2.org website is really useful. I think Luke will put this on his website, all of the resources that are pretty good when you're trying to create figures. That's the main one for this package, the ggplot2.org. If we actually go to it, is it open? Yeah. So this is how it looks like if you put the docs plan. It gives you all the different types of figures you can generate, the statistics, scales. You can see there's so many things you can do. And then if you like to select one of them, let's pick this one, for example. It gives you an example of how the code, the function is set up, and then what you can modify within that function and how the changes will look. So that's kind of the quantile thing that I showed earlier. And then the cookbookr.com graphs also is pretty good. There's a whole book about it. So if you have spare time, read the book. And then there's a Harvard tutorial thing. Did you say you're doing that? I don't know. You could take that one, and then there's a cheat sheet available with RStudio. So this is a really general overview of the different functions available. And I printed this and I stuck it on my wall, so it's easy access when I want to make figures. And then there's a bunch of YouTube videos too that you can look into that are good at explaining step by step the different types of changes you can make when you're generating figures and how to modify them based on what you want it to look like. And I'll send this to Luke to put into his website so that you can find them. Okay.